Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes in mathematics. Today, in the end of the lesson, we have some interesting questions also. Before we start with the lesson on circles, let us see the previous knowledge, what you have studied about circles. What is circle? And also you have seen about angles in the previous classes. How many types of angles are there? Come on. Acute angle, then right angle, obtuse angle, straight angle, reflex angle, and complete angle. Is it not? And also you studied about line segments. Line segment is a part of a straight line. What is a straight line? Straight line is collection of points which moves on either directions. So a line segment is a part of that line. So here this is a straight line and this part is called as line segment. This you already studied in your previous class, right? And also we have studied about drawing circles of given radius. Which instrument you use there? Yes, it is compass. Using compass, you draw a circle. What is a circle? Circle is the locus of a moving point which moves at fixed distance from a fixed point, right? Moves at a fixed distance from a fixed point, and the fixed point is called center of the circle, and the distance is called radius. Is it not? So how to draw this circle? Using a compass. You take a center and draw a circle of given radius. And how many radius you can draw in a circle? Any number. That's why you use the word radii. Is it not? And also you have studied about drawing lines perpendicular and parallel to a given lines. Perpendicular means what? And a line which is making 90 degrees with the given line. And parallel means a line which do not meet each other, the lines. For example, now the bars of the window, they do not meet each other. The distance between the two lines will be same. Is it not? So, parallel lines. Also, you have studied about parallel lines in your previous class about congruence of triangles. What is a triangle? Triangle is a figure having three line segment and have three vertices, namely A, B, C, right? And three angles. And you have studied about congruency of triangles. For example, if you have two triangles ABC and PQR, they are said to be congruent. And when they will become congruent, there are conditions, is it not? Say when the three sides of every triangle are equal to the three sides of the other triangle. We say the two triangles are congruent. So, how to write congruency? Triangle ABC is said to be congruent. You can draw like this, or you can draw three lines like this also. To PQR. And there are four conditions. This is about right angle triangle called as RHS congruence. And you have a SAS congruence. Two sides and one angle of one triangle, if they are equal to two sides and one included angle of the another triangle, then the two triangles are said to be congruent. Is it not? Similarly, if three sides of one triangle are equal to the corresponding sides of the other triangle, then we say the two triangles are congruent. Also, we have if two angles and one side of one triangle are equal to two angles and one side of the another triangle, we call it as ASA congruency. And lastly, in a right angle triangle, if one of the sides and hypotenuse of one triangle are equal to the other's corresponding side and the hypotenuse, then we say the two triangles are congruent. And this is the symbol I use, and this is already you have studied in the previous class, right? Today's topic is about some special properties of circles. I think all of you know cycling, right? So while cycling, what do you observe? The cycle is moving, the tire, or the shape of the tire, we call it as circles. And a road, if you take it, so the road will be like a straight line, and the tires are like circles. So when they move, they touch the road at one point, and as they move, the point moves. Is it not? So also if a coin is rolled, this is the coin. What is the shape of the coin? Shape of the coin is circle. And this surface, plane surface, tabletop, if you consider it a one straight line, it touches the surface at one point. So that's a very interesting thing we are going to study today. So if you roll a coin on a smooth surface, say a table or a floor, we find that at any instant of time, only one point of the coin comes in contact with the surface of a table or floor. So it touches at one point. Just as a cycle also we have, and some of you are experienced with the cycle, only the rim, not cycle, rim of the cycle is taken and you are pushing it with another rod. Is it not? There also you can see the movement of the circle. And if you consider the road as a line, the circle moves on the line and it touches at one point. Some name is to be given for that, right? So that is what you have to discuss today. Here is some cases. In the above examples, you observe that if a line touches a circle, so this we consider it as a line touching the circle. We shall study about the possible contacts that a line and a circle can have and try to study their properties. So we are going to study about the line and a circle. What are the different possibilities? which you come across in the daily life. Is it not? And see, these are the three possibilities. What is this? It is a circle. How do you define a circle? Just now we discussed. Circle is the locus of a moving point. Suppose the point is here. This moves. Locus means path traced by a moving point, which moves at fixed distance. This distance is fixed from a fixed point. What is that point called? Center. Is it not? So when you think of a line and a circle, here the line is different. There are three possibilities. First one is line is outside the circle. Second, line passes through the circle. Third one, the line touches the circle. Is it not? So when a mother calls a child, first the child will be in a distance. So it is just like this, in a distance. And then another possibility that the mother hugs the child. And another possibility just touches the child with a finger or whatever it is. So they are the three possibilities. What can we name them? Let us see. So we will have some interesting aspect about this. So this line, which does not intersect at all, it is called exterior line. No contact with circle. Second case, the line intersects the circle at two distinct points. See, it touches here at 2 points, namely A and B. In that case, a part of the line lies in the interior circle. So this lies inside. What do you call it? We call it as chord. Is it not? The 2 points of intersection lie on the circle, and the remaining portion lies in the exterior circle. So this portion comes out of the circle. So this is a second case. And in a third case, the line touches the circle at exactly 1 point. See, here it touches at 1 point. We therefore define the following. So these are the three possibilities in case of a circle and a line. Okay. So now our concern is about this case, special case, where a line touches the circle. How shall we name it? We will name it as, see, a line which touches the circle at exactly 1 point is called tangent. 1 point. And a point where it touches the circle is called point of contact. So this is called point of contact, P. In the figure below, xy is the tangent to the circle at P, and this is called tangent. So the line which touches the circle is called as tangent, and if it passes through a circle, it is called as secant. So note the difference between tangent and secant. Here the point of contact is only one. Alright. So note the difference between the two, which is very interesting case. And what is secant? It's a line which intersects the circle in two distinct points. See, A and B are called two distinct points. And this line is called secant line, or shortly called as secant. In the figure, xy is a secant to the line. A and B are called points of intersection of the line xy on the circle with the center O. So this is called secant. So line XY is called secant. When does a secant become tangent? When the secant comes and touches the circle at only one point, then we call it as tangent. How many secants you can draw? Any number of secants. How many tangents you can draw for a given circle? Any number of tangents. As many points are there, so many tangents you can draw. Is it not? So also secant. So I think you understood the meaning of the word secant and tangent. Now here is a very interesting case. Consider the secant xy. So let us suppose this is a secant xy which touches the circle in 2 points A and B. So these are the 2 points A and B. Imagine at one point A, which lies in the circle of the secant xy, is fixed. The secant rotates about A and intersecting the circle at B dash, B double dash, triple dash, 4 dash. So here what happens, this secant, if you go on rotating, see here, so it is touching here, the secant, at 2 distinct points. When you come up, A, B dash, A, B double dash, A, B triple dash, A, B 4 dash. At last, what happens when you start moving, it comes and touches at only one point, and that point is called point of contact. Point of contact. Then the secant XYBA, XABY becomes a tangent. Its name is XABY. Okay, so here it touches the circle at only one point. So I think you understand the difference between secant and tangent. In secant it touches the circle at 2 points, in tangent it touches at only one point. Do you think of any other property? Yes, there is one more property of tangent, and that is a tangent is a limiting position of a secant when the 2 points of intersection coincide. So here A, B are the 2 points, it becomes only one point, namely A. So it coincides. So AB becomes only one A. Okay. So that is a very, very interesting point that we study it as tangent. So, and one more interesting point is that a tangent XY be a tangent to a circle with center O. So this is a tangent. O is the center at the point P. Now if you join this O and P, we find that, so take points Q, R, S, T. So Q is here, R is here, S is here, T is here. These are all different distances. This is the shortest distance. We find that the shortest distance is P. OP is the shortest distance. And what do you call it? We call it as radius. So P is the point of contact, OP is the radius. And what is the angle there? This radius is always perpendicular to the tangent. Means angle is how much? Angle will be 90 degrees, right? So OP is less than all others. So OP is the shortest distance. OQ, OR, OS, OT, etc. They are all longer distance. Shortest distance is OP. Is it not? Suppose you want to go to Bangalore from Chikballapur. There are so many roads. Can go to Shitlaghatta and then Bangalore. can go to Durbalapur and then Bangalore. Is it not? And you can go to Vijaypura and then Bangalore. So there are so many roads. But it is the shortest distance. Shortest is via Devnalli, that highway, with the shortest distance. So also these are all different distances from the center to the tangent. But which is the shortest distance? That is radius. And the angle will be 90 degrees. And we write it as OP is perpendicular to, you can say, XY. So what is XY? Or you can write XPY. XPY is a tangent. XPY is a tangent. OP is the radius. And what is that P called? P is called point of contact. And how many tangents you can draw like that? At a given point you can draw only one. But for a given circle, you can draw many number of tangents. Okay. And one more thing is, from a previous study of geometry, we know that all segments that can be drawn from a point to the line, the perpendicular segment is the shortest. So OP is called the shortest. Okay, out of all other lines. So this we call it as radius. So OP is perpendicular to XY. Means the angle becomes 90 degrees. Perpendicular line. Okay. So thus we can state that a radius through the point of contact of the tangent to a circle is perpendicular to the tangent. So one more property of tangent, a radius is perpendicular to the tangent at the point of contact, not other points. That also you must note. Okay. So this is a very important property of a tangent. And the above result can also be verified by measuring angles OPX, OPY and finding each of them equal to 90 degrees. So you can draw one more circle, one more radius, measure angles. We find that all angles will be equal to 90 degrees. Okay. So that is another property of the tangent. Now here is one question, something like a puzzle. Can you work out? You have to answer in 3 minutes because there are 3 questions here. How many triangles are there? How many squares are there? How many rectangles are there in the given figure? Can you solve it? Think about that. For that you can give names also. A, B, C, D like that. This also you can give names and try to do it. Okay. Next class we will solve it. Okay. And then in this figure. So this is one question that are usually asked in NTSC exam or all competitive exams. And sometimes they extend this also figure. And it looks to be very simple. But when you work out, you will understand how deep it is. Okay. And let us come to the home assignment. First question. Fill in the blanks. A tangent is dashed to the radius through the point of contact. Second, a tangent is a limiting position of a secant when two dash coincide. Third one, differentiate between secant and a tangent to a circle. Okay, come prepared. Now before we close, we will see what Bhagavan says. Sadguru Madhusudan Sai speaks. Patience with oneself is hope. So if you have patience in yourself, whatever may come, sometimes good will happen, sometimes difficulties will come, challenges will come. But that is called as hope. And patience with others is love. So what does the love do? Love gives and forgives. self gets and forgets. So, if you have patience with others, then it is called as love. For example, small children will be there in home. They do lot of mistakes. They do all nuisance, make all sounds. But you will bear with them because you have love for the children. So that is called as patience with others. And patience with God is faith. Whatever may happen, it is for my good only. And everything is done by God only, we think so. So that is what is called as patience with God is faith. Okay. Shall we close now? Okay. Thank you.